This week, we're going to talk about the design of data. And what we're going to see is that the design of data really turns out to be a point of leverage in designing programs. Because when we design data, we make decisions about all the functions that later operate on that data. But before we get to that, this video covers cond expressions, which are a new kind of expression in Racket that's going to let us program conditional behavior where there's more than just two cases. I have the constarter.racket file open from the lecture page. And let's just look at this file quickly. It starts by defining three constants called I1, I2, and I3. And they're all three rectangles. And let's see, one is 10 wide and 20 high, and the I2 is 20 by 20, and I3 is 20 by 10. So these are three rectangles of different shapes. And now here's a function design, and the function consumes an image and produces a string. And let's see, it produces the shape of the image, one of tall, square, or wide. And these three examples / check expects really help me understand this function. If I ask for the aspect ratio of I1, I get tall, whereas for I2 I get squared, and for I3 I get wide. In reading through the rest of this, there's a stub and a template that are commented out. And now when we look at the definition of the function, what does it say? It says, well, if the height of the image is greater than the width of the image, then produce tall. That's this whole if there. And that's its question, and that's its true answer. On the other hand, let's see, its false answer is another if that asks if the image height and width are equal, produce square, otherwise produce wide. So this function design works, and if I run it, I'll get what I want. But there is something I'm not entirely happy about here. If you think about this function, there are really three cases, right? There's the tall case, the square case, and the wide case. And those three cases really feel like they're parallel to me. They feel like they're corresponding cases. Whereas when we implement them here with if, we end up having one case, tall, which has two other cases, square and wide, kind of inside of it. And that doesn't feel quite right. It doesn't feel quite right to have one case with two inside of it as opposed to three parallel cases. So what we're going to learn in this video is a new mechanism called cond. That's what's called a multi-armed conditional. And that is something we can use when we want to make an expression that has different behavior depending on the answer to predicates. But there's more than two different options. So here we go. Let's do it to this one. Let me first show you a new trick. If I do sharp sign semicolon, that's going to comment out the entire all of that stuff. It basically comments out from balanced parentheses to balanced parentheses. It's easier than putting a semicolon before each line. And now let's redo this function. I'll say define aspect ratio image. And what I have is three cases. So what I'm going to do is I'm going to write cond. And then there's three cases, and each case has a question and an answer. And there's three of them. So I'll just copy that like that. Oh, and I spelled the name of it wrong. Now notice something here, which is that I'm using square brackets instead of round parentheses around the question and answer pair. That's just a convention to make the question and answer pairs stand out better, particularly when they get larger. Square brackets and round parentheses are really treated the same by Racket. Square brackets balance each other and round parentheses balance each other. You could use round parentheses here, but square brackets just makes it look a little bit better. Now what's the question for the first case? Well, the question for the first case is actually right here. I'll take that and I'll replace that question with it. And if that question is true, then what's the answer? Well, the answer is right here. Tall. And what's the question for the second case? Well, the question for the second case is right here. And the answer for the second case is right there. And then what's the question for the third case? Well, the third case is the last case. It's the in all other cases case. And so there's a special question that we could put there called else, which means if it wasn't the first one or the second one, just do this. And the answer for the last case is wide. Let me first run this to make sure I haven't made any mistakes. I haven't, and it's working. And so the way I want to read this is it says, gee, there's multiple conditions. If image height is greater than image width, then produce this result. Evaluate this expression and produce that result. If image height is equal to image width, evaluate this expression and produce that result. Otherwise, or else, evaluate that expression and produce that result. And that's kind of nice. What that gets me is multiple questions, kind of all at the same level of nesting, all at the same level of importance in some sense. So cond is a good thing to use for multiple case expressions when there's more than two cases. You can use if and nest them the way we have up here, but it tends to read more easily if you use cond when there's more than two cases. Now we'll do the usual thing and look at the rules for forming a cond expression. It's just open paren cond, and then one or more question-answer pairs, where each question-answer pair is open bracket, a question expression, and then an answer expression and a closed bracket. And all of the question expressions have to produce a Boolean, except the last question expression, which is allowed to be the special word else, which is going to mean if you get to this question-answer pair, definitely produce this answer. To look at the rules for evaluating cond, what I want to do is work with a slightly simpler example. So what I'm going to do is make a new tab, and here's my simpler example. And I'll do the usual thing about putting the evaluation rules for cond off to the right here. And now let's get going. We start evaluating and we see open paren cond. So this is a cond expression and we have to use the rules for cond. There are question-answer pairs, so there's no error. And let's see, the first question right here is not a value, it's an expression. So we need to evaluate it. Well, let's see, evaluating it, it's open paren greater than, it's a call to a primitive, so we would use the call to a primitive rule. Both operands are already values, so we can apply the primitive directly. So this greater than 1, 2 is going to produce false. So what we're going to do is replace the entire cond with a cond in which the first question is false. Now we start evaluating again. Open paren cond, it's a cond. Let's see, the first question is false, so that takes us to the if the first question is false rule. And what that rule wants us to do is drop the first question-answer pair. So what we get now is a new cond in which this first question-answer pair is going to be deleted entirely. I'm going to do Command E now to get myself more room here. Okay, let's see, open paren cond. There are question-answer pairs. The first question is not a value, it's an expression. So I need to evaluate the first question and replace the question with its value. Well, we know how to do that now. That just gives me false again. Open paren cond, there are question-answer pairs. The first question is false. So again, it's the drop the first question rule. So we basically drop the first question. Open paren cond, there are questions. The first question is not a value, it's an expression. I evaluate it. Okay, we're getting there. We're getting very close now. That is now true. Open paren cond, the first question is true. Now I replace the entire cond with the first answer expression. Okay, let's see, what do I have now? Oh, I have a value. I'm done evaluating. The key intuition is that the way the evaluation of cond works is it evaluates the first question. If it's false, it drops that question-answer pair and starts over. If the first question is true, then it replaces the entire cond with the first answer. You can see here an interesting pattern, right, which is the rule for cond, the rule for function call, the rule for if, they all work the same way. They, in some sense, try to do their thing and then get out of the way. Right here in this last step with cond, once we got to the answer, the cond was gone. And that's the same thing that happened with function call. Once the body of the function is replaced in, the function call itself is gone. These style of evaluation rules work that way. The idea is to take care of the more sophisticated construct and then get it out of the program. Okay, here's another example for you to do stepping. It's a little bit more complicated. I apologize for all these stepping examples, but we know that they really help people in terms of mastering how the language works, and that really starts to help as the programs get more complicated. So here's another example of that as an exercise, but it'll be interactive so that you can kind of work through it as you go.